Hey, what's up, guys? Chung here. So this time, let's talk about another DP problem, number 1326. Minimum number of taps to water to open to water a garden. So basically, you're given like a number of gardens, right, from 0 to 5, and also another array of the taps. So at each tap, on each tab, the range this tab can water is from the index itself plus the range itself. Basically, the value of this, the value of this element here is the range starting from the current index. So, for example, 4 here, right? From starting from index 2, from index 1, it can go right to range 4, and this side also 4, right? So that's the range. Okay, so how are we thinking about this problem, right? So, you know, we can think it in this way, right? So every time, let's say we just iterate each of the tab here, right? So we can get the left and the right, right? With the current index and the number of the range itself, we can get the left and the right, right? Basically, that's the range this current like tab can water, right? And then we define a DP here, right? The DPI. So what does DPI means? DPI means the minimum like tap uh needed to be watered to garden I here, to garden I. So DP2 means, right? DP2 means how many gardens, right? So from garden 0 to 2, right? What's the minimum taps we need for DPI, right? Okay, and then what does the DPI means, right? So let's say every time we have this range from left to right, right? And then we know with current like taps to left to in the range of left to right, in the range left to right, right? Let's say there's like a J here, right? J. So any DPJ here, right? Any DPJ, right? So because the current tab will take one, right? Would take one. How about the previous one, right? Then the previous one will be like DP left, right? DP left, right? So that's DP left means from whatever whatever it took to water to water until the left one. So now, since with the current tab, all we need is the plus one, right? Because with the plus one, we know we can range from we can water all the range from left to right. So within the left and right, all the DPs we can update it with the current DP left and plus one, right? And in the end, we just check the DP n here. Yeah, that's the kind of brute force DP solutions. And okay, let's try to code it here. Okay, so DP, right? So since we're trying to get the minimum, so we're gonna initialize all the values to system max, right? And then the value will be n plus one, right? Because we need the first one to be dp0 to be 0. Basically, that's the base case. If it's 0, if it doesn't have any gardens, we need 0 tap to water it, right? And then we just loop through for I in range uh, in range n, right? So for each of the tab here, uh, for each of the tab, yeah, sorry, actually the let's see. So we range the range here, the tab range, right? In enumerate like ranges, right? We get the left and right, right? So what's the left? The left is gonna, since we're bounded, right, from the zero to the of the left, and also the n to the right, right? So whatever is over this two-side boundaries we don't care, right? So then we need to do a minimum here. Sorry, a maximum, right? Since we're doing a bounded with zero, and the current I minus tab range, right? So that's our left boundaries here. How about the right? Right boundary is going to be the minimum, right? On the other minimum n, right? That's the right boundary, I plus tab range, right? Then for j in range left and right, right? Since we're doing our since the two is exclusive, so we just do a right plus one. For every element in the range left to right, right? And then dpj, right, equals to what? Equals to the, okay, so since we're doing the minimum, right? So we're gonna do like a minimum every time we do a j here. And then what? So dp left, right? So every time, if we have the left until the left, right, and then we know if on the left we took like a k times, so then the next time we only need to use k plus one to water until the current j, because the current range can range everything from left to right, right? So, and in the end we just return dpn, right? Dpn here, dpn if, right, if this dpn is smaller than the system max, right? Because that's we are sure this like dpn until this n has been watered, right? Otherwise, right, we just return a minus one, right? That should do it. Yeah, cool. Yeah, it's not a very hard problem, but it takes some time to think of a way of doing this DP. You know, this is not the fastest solutions, but I think this is like a more intuitive way of thinking about this. Basically, for each of the range here, we get the left and the right, and then here's the idea. So within the range left and right, right? Since we define a DP here, so DP means starting from zero to current J, what's the minimum tabs we need to water everything, right? So since we have left and right, and for each element in the range left and to right, then we can get the DP left. Basically, how many tabs we need to water until left, and then we plus one. That's the value in the DPJ, right? And we try basically all the ranges possibilities, and we keep updating the J's. In the end, we'll get the DPN. Hmm. Yeah, cool. I think that should do it. Yeah, I think that's everything I want to talk about this problem. Uh, cool guys. Thank you so much for watching the video, and see you guys later. Bye.